very hard and not very useful when you have all these intertwined steps that really lack any kind of controllability and lack the versatility required to make ROAIF work very well, right? So the hard part, the re-ranker, starting with a helpful LM only, and then having to filter such that you have like maximum controllability over the different generations is major issues that have plagued ROAAF really for the last like year. So that's actually where direct principal feedback comes in, which is the technique that I developed for this paper, where you still start with a helpful LM. It doesn't need to be exclusively helpful. It actually doesn't really matter that much, unlike the constitutional AI approach. But you generate a response, you critique and revise the response, and in the critique and revision step, you actually specify the exact kind of controllability that you want. So here, I generate an utterance that contains the pink elephant, and then I critique and revise to remove the pink elephant from the utterance, and I replace it with the gray elephant. And by having this controllability, which is not really something that's even feasible with constitutional AI, solving the pink elephant problem becomes something very viable. And sorry, third question.
No worries. On my side, just the question is, how do you in practice actually do the critique and revision? When I say that, I mean which LLMs tend to work nicely. You just use GPT-4, or like what's the reason there?
So we will eventually release some of the pink elephant models in the near future. They aren't out yet. We're literally still working on the model cards right now, and we're trying to like maximize transparency. I didn't want to do this. I didn't want to release the models if they were just trained on GPT-4 outputs. So we actually use Llama 2, the 7dB model. And I know on benchmark, 7dB is not as performant as it may seem compared to like Mixtral or compared to other open source models now. But we actually find that on critique and revision pipelines, 7dB is still your best bet for open source. Like there are certain things that we're just not capturing at all with evaluations that are absolutely necessary for doing critique and evaluation. And it's like there are certain, it's very much an open problem to create an evaluation benchmark for like how good is this model as a critic, or how good is this model as doing revisions. Like no one knows how to evaluate that at all yet.
Mm-hmm. Interesting. How did you figure out that 7dB, Llama 7dB is better than the alternatives? What was your...
I tried everything. So I think the pink elephants data set is about what we generated was about 700,000 dialogues, right? I think in total, between all of the failed attempts, I probably generated anywhere from like 8 to 9 million dialogues. So I had a lot of failed attempts. It was a lot of learning to find that Llama 2 is really the best model for this. And actually, Nathan Lambert and I just did a podcast yesterday for Interconnects, where we talked about like how good are these models at like being reward models, and it turns out Llama 2 7dB is still the best reward model compared to like anything else by like a huge margin.
That's interesting.
Mm-hmm.
Thanks.
No problem. No problem. Was there another question? I might have missed one. All right.
Let me see in the chat. Nope, it was just me.
Okay. Okie dokie. Okay. So we have this approach to like maximize controllability and build this fully controllable system. And one really important thing about direct principal feedback is that it was concurrent work with something that Kosta Huang did at Hugging Face for building a constitutional AI data set. However, he focused on just extrapolating the constitutional AI work to this direct principal feedback based approach. Whereas we see direct principal feedback as an entirely new paradigm of like ROAIF controllability. And really it opens the door to so many new alignment problems that like simply were not feasible just a few months ago. So like the fact that you have this added controllability in like generating positive trajectories versus negative trajectories really is like a game changer in like so many different things. Like it like changes how we should start thinking about hallucinations for ROAIF. It changes how we should start thinking about retrieval for ROAIF, tool use. I could go on and on and on, but like really, it is I if you have one takeaway from this presentation, it should be that direct principal feedback um, is the way that you should be generating RLAIF data because it just makes so much more sense with PPO than doing constitutional AI.
Nice. And also for generating racially diverse samples, how do you go about doing that? Like the recent thing we saw, the recent saga with Gemini that happened online, like how does one really solve such an issue? What's your thinking there?
So,
like, can you even do it with a single centralized model? Do you have to have some personalized models? But then again, how do we avoid falling into subjective truths and like postmodernism or whatnot?
So diversity has always been an issue for RLAIF. There's no way around that. At the moment, there is no catch-all solution. And I think if you take the mindset that a catch-all solution exists, it's almost how you end up like situations like Gemini. I think that in the case of the Pink Elephants paper, we were able to get a very, very diverse data set. And actually, I'm going to skip around a little bit and I'll go back. We were able to get a very, very diverse data set by generating very, very unique pink elephant pairs. So, you know, don't say this, say that. We like generated a bunch by hand. We used them as seeds, and then we passed them to like GPT-4 and Llama 2, and we had those generate more, and then we would filter them down to like remove any like lack of diversity. And it was a very long iterative process that lasted about a few weeks to really get like the most diverse set of topics that we would want to discuss for pink elephants. So the final data set has 161,775 data points, right? For that, we generated about 4,000 topics, like very general topics, to cover this space. And we found that of those 4,000, 3,469 of them were unique. And when I say unique, it's not like string match. It's like embedding wise, they were unique. It was so it is a relatively diverse data set. And over
and
here,
when you say unique values, you kind of have like some clustering, and then you have 3,000 centroids using GT base, or what? If I can see there on the screen, is that the logic?
Yeah,
makes sense.
Yeah, so it is a very diverse data set, which I was extremely happy about. Over here on the right, you can see some of the stuff that we rejected. And it's really like anything that was like as an AI language model, I cannot yada yada yada. Anything like that was rejected. So these are all the kinds of filters that we were using.
Sure. Makes sense.
This is on a very small sample of the data set. So we'll go back and we'll talk about the data pipeline in more detail about all the cleaning that we did. Sorry, one second. By the way, I do have a hard stop at 55 after.
That's fine. I think we'll definitely have time.
Okay. So yeah, so the data set pipeline, you know, diversity was our main focus here.
Chat, huh?
We generated a bunch of seed topics. We hand wrote like 27 seed topics. And when I say we hand wrote, it was like me and two other authors in a conference room for like 6 hours trying to figure out how to cover the most diverse set of pink elephant pairs.
Nice work, guys.
And really, like I think like stuff like that is really at least at the moment the solution to getting these diverse data sets is that you really need very smart people in a room trying to understand exactly the problem you're trying to solve and how to maximize diversity. And you know, that as well, like people underestimate how important it is just to talk to your co-authors and really understand the problem. People like to glance over that part in the research process.
Do you think you can actually avoid, like, what's the pros and cons of having 3 smart folks versus just like outsourcing it or crowdsourcing collection of the seed prompts to like?
Oh, we
massive
tried.
Difference.
Yeah, so we actually tried outsourcing initially because we came up with the Pink Elephants paper during a hackathon. back in August.
Interesting.
Yeah, back in August. And we tried crowdsourcing to people at the hackathon, and every other topic was a duplicate. It's using the community to generate diverse devs, I think is a pretty bad idea. People are not very good at diversity unless they approach it from a very systematic point of view. Actually, there's a paper that I worked on when I was at Harper that was saying like how much better language models are at diversity than humans. And like really it comes down to like if you just feed a language model very well, you'll get a very diverse data set. Whereas if you feed a human very well, it's not that diverse. Like humans like to repeat things. Humans, like if you ask a human for a random number, it's probably not going to be a random number.
Yeah, I agree. That's why arena types of evaluations are also not enough, right? Unless you prompt humans somehow to diverse topics, people usually just ask very similar questions. We like to think we're much different than we are. But like what I was getting at is actually explicitly prompting much more folks to think across broad topics, and then you can have like one group has a certain subset of topics that they use to generate seeds, and then you can distribute and split, parallelize the work like that.
That's a deeply fascinating question for future work. I think we gave ourselves the timeline of about 2 to 3 weeks to generate the seed topics, to generate all, like I think we generated the final list that we generated was 700,000 seed topics. So we had pink elephant, gray elephant, and then the discussion, right? So we would, if you had like British universities, American universities, then the discussion might be like dormitories, right? So now we have a throuple, and that is one subject of conversation. So we have an agent that talks about British universities. The user wants to talk about American universities, and they're talking about dormitories, and that the user is trying to get the agent to talk about American universities. And spending about 3 weeks on this, roughly, got us a very, very diverse data set that we were very happy with. And I think that if we had done this with humans, it would have been a little bit better if like we constructed the experiment extremely carefully. I don't think it would have been massively better. And because it wouldn't have been massively better, you know, the time is best spent somewhere else.
Makes sense.
But it is a very interesting research question. I do think that like in the future at some point maybe we can there will be a study on like generating seeds for RLAIF versus like getting humans to write seeds, and really like what is the performance difference that you should expect. But I don't think that it will be more than maybe like a 10% downstream performance, honestly. And I think that your timeline goes for generating seeds goes from weeks to months. So we have in the beginning step 1 here, figure 3. These are all pulled from the paper, by the way, which I think is linked in the event. I'm not sure. In figure 3, we talk about generating the discussion. So we generate the seed topic, pink elephant pairs, and then for every pink elephant pair, we generate a bunch of like conversations. So we have like, you know, the seed topics might be like universities, and then we generate like British universities, American universities, and then we generate dormitories, food, classes, whatever. Like it doesn't matter. And then once we have this, we generate the initial dialogue. And I actually found that the way to get the most like natural feeling diverse dialogue was to do what I like to call, well, not what I like to call, what is called plan and write. You write a plan for how the user will trick the agent into talking about American universities. And you have to make sure that only on the last step of the plan does the agent mention American universities, and you generate the dialogue under that constraint. And the reason you want to focus on the last utterance is because when you rewrite the last utterance, right, you don't want to mention of American universities before that, because now all of a sudden your RL AIF data is tainted. And maintaining high data quality is one of the keys to getting Pink Elephant to work really well. It took us about, sorry, I'm a little congested. methodologies. It took us about 3 months to generate the data set, and then it took us about another 3 months to clean it and to understand what it is that we generated. And we learned a lot about cleaning. I don't think it would take us 3 months now. I think it would take us about a week. But understanding all of the processes involved in generating data and trying to minimize any contamination very early on is an extremely important thing to keep in the back of your mind.
We question on the figure 3. I see you use tabled beluga to generate these subtopics. What's the reasoning there? It was again one of these things we tried a couple of things and this gave the best results, or?
I mean, I'm a little biased. I worked on Stable Beluga too when I was at Stability. So I like it. That's part of the reason. I quantized it a lot. Like early on into these experiments, and because I quantized it a lot, I didn't want to have to deal with quantizing more models. So like I tried like 20 models, Stable Beluga worked the best, so I just quantized it, and then I didn't experiment with any new models until we were done.
And maybe even more important, like how do we as a community go around not using GPT-4 given the terms of service of their models?
Yeah, I actually don't think we needed to use GPT-4 at any step during this. So the only reason why we used GPT-4 in the very beginning was because the pink elephant pairs were generated from the seed topics during the hackathon that I mentioned. And setting up an inference endpoint during a hackathon is a non-trivial task. We just found it easier to write a script to call a GPT-4 endpoint. There really is no reason that you have to use it, though. I have rerun that step with Llama 2, and it works totally fine, and there are almost no issues. I think that this paper should stand as a note that you can really do a full end-to-end RLAIF pipeline without any use of GPT-4 whatsoever, and without any use of RLHF models in your pipeline. The only thing that is RLHF in this entire pipeline is the output model and the models that we use to evaluate.
Makes sense.
So once we have the dialogue, we need to critique. Pretty straightforward. We critique and we say, where did in the last utterance was mentioned, and we cite it. And really, the important thing is making sure that it can directly cite in the last utterance where the pink elephant was mentioned. And we actually found that if we didn't ask it to cite it, it would just hallucinate random reasons why the pink elephant was mentioned. But if we ask it to cite it, it's just copy the sentence or copy the word or copy those few words around it. It was much less likely to hallucinate and correctly and pretty consistently correctly identified when the pink elephant was mentioned. So any dialogue that didn't mention the pink elephant was thrown away at this step, and I think that we threw away about 2 to 3% of the dialogue. Because this was getting a model to talk about the pink elephant when we're trying to encourage it to talk about the pink elephant was a relatively easy task. So only 2 to 3% of them didn't actually mention the pink elephant. So we didn't have to throw away much here. And then revision was easy. Most revision prompts are the same, and they're mostly just take the critique, take the input dialogue, and rewrite the last utterance to conform to the style of the dialogue, and take the input of the critique to guide your decisions in the changing verbiage. Nothing crazy. We did find at one point that if we weren't careful, the critique step would also try rewriting the dialogue, and we actually had to very intentionally remove anything in quotations from the critique that was not an exact quote from the original dialogue to avoid overfitting.
Nice.
So once we had dialogue paired, we then filtered again to make sure that the revised version removed the pink elephant. We actually, at this step, threw away about 33% of our data. That was very unfortunate, and I was very unhappy. But it's even when you're asking a model to remove the pink elephant, it's not very good at it. So we did like cosine similarity, Levenstein distance. I don't know if I'm pronouncing that right. I think I am. And then we did like just edit distance, like Hamming distance, and we used like a threshold of like 0.8 for cosine similarity for like the Stilbert Levenstein distance. We wanted to like, I don't remember what our threshold was for that. I think it was 0.9 or something. And then Hamming distance, I don't remember as well what our threshold was. I don't really think it matters. It's in the paper. And then at the end of the day, we had a filtered data set. At that point, we had a data set that could be immediately fed into DPO. From the beginning of the step here, you know, this was about 3 weeks. This here was about a month and a half. This step was about a month, I guess. And then this step here was like 3 months. This last cleaning step was very difficult.
Nice. Question, you mentioned Hamming distance, like remind me again, isn't that just doing XOR on when you have bit strings or whatnot? Like, so how does Hamming actually play here with text? Levenstein is basically the edit distance, right, between the strings. But how does Hamming play into the picture here?
Oh no, sorry, you're right. It's Levenstein and then exact string math. Yes, sorry.
Okay.
Misremembered. My bad.
No worries. And so let me just understand again. Figure 6, you have dialogues. So you have the initial one where the model actually mentions the pink elephant. Then you have the revised dialogues. You pair those, and then when you say you're filtering them, what exactly are you filtering if you already?
Yeah. So we filter on whether or not the revised one actually still mentions the pink elephant, and if it does, we remove it.
Got it. And that's where you use all of these various. Got it.
Yep.
And you said like 50% you kind of kept it throughout due to this.
Yeah, it was very unfortunate. We had to throw out a lot more data after that. Things where it's like the last utterance wasn't the agent proved to be an issue. So like if the user said the last thing, like we had to throw it out because we always wanted the agent to say the last utterance because it wouldn't make sense to revise the user's utterance. At the end of the day, we went from going here, we went from about 700,000 dialogues to 161,000. So we had to throw away most of our dialogues. But it's okay because throwing away synthetic dialogues is not that big of a deal. It's much less of a deal than throwing away human annotated dialogues. Actually, I think it was something that I learned, which is a very important lesson. Always generate about 10 times more than you think you need.
Yep, that makes sense. And luckily, I guess, how did you host like stable Beluga and stuff? Were you just running on your local machines, or actually had some API you can share with the team, or?
We just had some A100s that we would host it on and call it from there. Like we had I think like 48 A100s that were just like hosting the LLM.
Nice.
So,
yeah, I'm asking because of the cost. If it was GPT-4, you don't want to throw 50% easily.
Even then, it's not that bad. Like, I think in total, we probably generated anywhere from like 6 to 7 billion tokens, right? That's like still not that bad for GPT-4. Like, think about it this way, right? And when I say that, I mean for like the entire data set. So like, you know, all the iterations are probably a significant larger amount of tokens than that. And like, if you think about 6 to 7 billion tokens, it's what, like maybe $30,000, $40,000 with GPT-4. It's like that's not bad. Like that's within the range of a very large number of academic labs, which I think is really something to note here. It's like it's not in the range of like average hackers, but like if you're like a professor at like a big university, that's within budget almost. Like it's not unreasonable, and that price is just going to continue to go down. Okay, this is just like the distribution of topics. Oh, sorry, who has a question?
I think Sergey had a question. Sergey, you want to ask it yourself?
Oh, by the way, I forgot to mention, I have the stochastic parrot tag split skated for me yesterday. I wanted to show it off during the AI technique thing.
Nice. Okay, I can read Sergey's question. So how well did the model generalize after the direct preference fine-tuning? Was the model able to apply the learned behavior to different scenarios? I.e., if you train on universities, does it generalize to brands, or does that require specific retraining?
It did not require any retraining whatsoever. And actually, we'll get to that in a bit. I have a slide on this, but like it generalized extremely well. It's right after this. I mean, I'm literally just about to talk about that, about generalization. So we'll get to that in a bit. But in terms of like losing capabilities, we saw almost no performance drop in empty bench and LM without harness benchmarks, like almost nothing. So it was almost a free capability that just took a bit of data to get out of the model.
Interesting.
And at the end of the day, our 13 billion parameter model performed within margin of error of GPT-4.
Nice. I mean, this is expected. You do take a model that already has all that knowledge, and you just kind of teach it this new skill of ignoring the pink elephant.
Yeah, it's something. It's something that I think DPF is really designed for. It's not for adding new capabilities. It's for specifying with very, very, very high controllability the exact behavior that you want. It's significantly higher controllability than anything else you can do with other RLAIF techniques. And previously, controllability that was only available if you paid like very high skilled human annotators. Okay, so we have the distribution of topics, like 2% was about music, 1.8% was about amusement park, 1.4 was about like repetition, cooking, philosophy, historical figures, recreation, sports, entertainment, education, board games, video games. Like the slides in the chat, if people want to look through this in more detail, you can feel free. I'm not entirely sure what like this refers to. Like, well, I know it's like 40% of like board games was about reviews, but like it doesn't break down into like subcategories very effectively. I don't know, but I really like Lilac. It's a great tool, and I'm gonna show it for like a second or two because I really do recommend that people get it. It is free.
What is it?
So can you repeat? Did you just say what's the tool name, or I didn't hear
Lilac.
the last?
Lilac.
Okay.
Lilac. Oh,
Yeah,
nice.
it's an open source data visualization tool.
yeah, Lilac is amazing.
It
Use it if you
It
don't.
is very good.
And the categories we see on the screen, board games, that's just like the seed prompt, right? Or the categories of seed prompts.
Lilac, as far as I'm aware, clusters your data, and it's really sick. It clusters your data, and then it passes clusters to GPT-4 to label them, and it's a godsend really for like synthetic data. It's amazing. I really like it.
Nice. Okay, so you basically label the conversations itself, not the seed prompts itself. Okay.
Yeah. And then it does like subcategories for you, and it makes it very easy to understand like what your distribution actually looks like. Okay, so the fundamental advantages of DPF, really it's all like controllability. As I've been saying, you can do new problems that you couldn't do before. You don't need to start with the good pair, the good example, and go to the bad example. You can start with the bad example and go to the good example. So like, if you can identify when a model successfully executes a certain behavior, you can reinforce that by using DPF to rewrite it so that it's a bad example, and now all of a sudden you have another DPO pair. So like the level of controllability that you get here is like actually mind-boggling and incredibly exciting. I genuinely think that like 6 months to a year from now, like most people will be using DPF or some variant of DPF to generate synthetic data. And also you get dynamic control. And this isn't a DPF thing. This was just a pink elephant thing. When we release the model soon, you'll be able to just put into the context of the model the pink and the gray elephant, and it will never mention the pink elephant, or not never, usually not mention the pink elephant, and occasionally mention the gray elephant, right? And this level of dynamic control allows the end user to decide how they want their model aligned. And actually, a generalization of that Nathan Lambert and I are working on right now is that we're doing this for like constitutional AI. So at runtime, you can rewrite and insert different constitutions that are potentially massively different than anything that the model was trained on, and it does generalize pretty well. So it is very exciting.
Interesting. That's really interesting.
And then just for
actually.
performance, you know, our DPF model performs within margin of error, basically of GPT-4, and some of these models, even with a prompt, right? When you tell it don't talk about the pink elephant, it's more likely to talk about the pink elephant than without a prompt that says don't talk about it. Even GPT-4, the margin's not that big. The margin is actually way bigger on our DPF models, and it's extremely exciting. Is it? No, they're about the same size. Okay, well that makes more sense. I misremembered a result. And I think actually one of the things that was super fascinating, there's more details in this in the paper, when you use stuff like negative prompting, which people typically say is like the solution to something like this, right?
No, it's not.
It gets worse. If you use negative prompting to remove the pink elephant, we actually found that it mentions the pink elephant significantly more. So you actually
Or
can't
wait,
apply
do they
negative
mean
prompting
like
here at all.
stable diffusion
Yeah,
style
by negative prompt, you
like the one
basically
you
mean,
get on
hey, don't
automatic?
mention topic X explicitly, and then the
No,
model mentions it, or
so with classifier-free guidance, right? Like negative prompting, like in like
Got
the
it.
diffusion way, but applied to language models.
Interesting.
So
That's
like,
really weird.
so like, you know, embedding the prompt of like the pink elephant, and then just subtracting like the latent vector from your latent vector that you're doing forward passes on.
That's so
Which
weird.
Stella Bitterman has a paper that like it works really well to do negative prompting for like certain kinds of evaluations. But here we actually find that using negative prompting degrades the performance of the model significantly.
interesting. I know we had this question also online. People were asking like, was this necessary? We have negative prompt. Simply put elephant in the negative prompt, and the elephant won't be there. And then that seemed to be the most common question for this paper that we saw online.
Yeah. We should have made it a bit more clear how unhelpful negative prompting is in this situation.
Mm-hmm.
So future ideas, you know, more complex constraints. That's a paper I'm working on right now with Nathan Lambert, as well as the second point. So flexible safety training, being able to swap constitution rules in and out or write entirely new constitution rules. And then there's just more research that I have to do into generating better synthetic data. So this was like since August, and like half of that was just learning how to generate really, really good RLAIF data. And there's still so much more to learn, and I'm just super excited to really dig into all of that.
Super cool.
That's
Maybe go back.
Sorry.
If you can go back to the previous slide, that one. Help me understand again the how to interpret the table. So we have what, open Hermes.
Yeah.
What's your model? Which ones are? Yeah, I'm trying to just interpret the table here
So
on the fly.
the with DPF is our model, right?
Okay.
And the other ones are just SFT.
Mm-hmm.
So DPF doesn't actually do an SFT step at all, because the trajectories are taken from the model that you're applying RLHF to. So we do not have an SFT step.
Mm-hmm. And then we have the base rate and with prompt columns. What do you mean exactly by base rate?
So the base rate is like, you know, in the example of British universities, we tell an agent that it is a sales rep for British universities. We do not tell it that it cannot mention American universities. And then we have an adversary ask it about American universities. And then with prompt is when we tell it you cannot mention American universities, and then we still have an adversary ask it. And with prompt, it's still extremely likely to answer about American universities, even when it's explicitly told not to.
Got it. So base rate is basically baseline, which is just a model performing without any special techniques.
Yep.
Got it. Okay. And then the delta is just the difference between the columns. Okay.
Yes.
And so So it performs on par with GPT-4. So why is Llama? I'm just looking at Llama 2 row there. Okay.
Llama 2 has no RLHF for a task like this, like at all. Well, it might. We don't really know, but presumably it doesn't.
Makes sense. I was just interpreting delta in an opposite direction, so I was thinking, oh, Llama has better results, which is weird. But yeah, you actually want bigger number there. Got it.
Yes.
Super cool. I don't know if folks from the audience have any questions. We have Luis for a couple more minutes before he has to jump off. What was the hardest part about this research? You said you started in August. You roughly broke down how many months you needed for each of the stages. What was the biggest difficulty? And yeah,
there really was data cleaning. Like data cleaning is not it's not easy. It's not sexy work. It was the hardest part.
Pain points, everybody.
That's weird. That's definitely something that learning. I'm still trying to kind of make peace with the fact that those easiest tasks, intellectually at least, are turned out to be the most important ones.
Good data cleaning was a make or break thing. Like this result, we were getting like half the performance without data cleaning.
Wow.
Do you see synthetic data as a way to get around all the issues of copyright? And it's a very loaded question. I'm going to decline to answer that one. I'm sorry.
Nice.
I worry. Yeah, it's a very loaded question. I kind of don't want to comment on it.
Yeah, I mean, it's a difficult one because how was the model trained that you're using to generate synthetic data? And then like there's all these questions, right, along the way, which are completely in the gray area. So yeah, you don't have to answer this one.
There was
the
something.
critiques of really the process rather than cleaning the initial dialogue and then just asking to rephrase the last line. It is because sometimes the way that the pink elephant is mentioned is highly nuanced. Which is actually something that I directly observed. It's not very often it doesn't mention the pink elephant directly. I feel like if it's talking about Disney, for instance, it'll like mention an attraction just at Disney World. And unless you have the critique step, which like identifies those issues and then suggests strategies to rewrite them, you'll find that it just doesn't remove certain things as effectively. Like the critique step is definitely necessary, and beyond that, right? Like imagine it's a more complicated task and you need to do multiple critiques and revisions. The critique step is where you learn when you know how to do early stopping. If the critique step says no, there's no pink elephant mentioned, you can early stop. But without the critique step, there's no real evaluation step, and there's no real way to say, oh, I've been making improvement.
Got it. Basically, he was assuming that only in the last part is where the pink elephant is mentioned. But what can happen if you don't want the chatbot to talk about Disney, but then it starts talking about Toy Stories or something more subtle in that sense, right? So then you can just like focus on the last sentence or such heuristics.
Absolutely.
Yeah, but then for those types of situations, then even Levenstein distance and some of those more like string-based superficial metrics won't work. You need to have something that
which is exactly why we use bird embedding.
Makes sense. Okay, we have last one. It's very interesting to me that the CFG negative prompt actually causes the undesired behavior more often. My understanding was that CFG would constrain the grammars such that it couldn't generate tokens that match the constraints and bias the surrounding weights heavily negatively. Do you have a hypothesis on why that's occurring?
I wish I did. I've talked to the CFG authors a little bit, and they're like, "Wow, that's really fascinating. Like, let me know if you figure anything out." It's definitely an interesting future direction. I think that I have so many papers I'm already working on, but I mean, if people here are interested in that, I would be happy to connect them to the CFG authors.
Awesome. Super cool. Maybe we can do that in Discord as well. If somebody wants to follow up and help run this.
Okay.
Nice.
Well, it was great seeing all of you. I have to run, but it was incredible fun.
Great.
Thank you.
Lois, thanks for joining. This was super cool.
Yeah.
Thanks.
Bye-bye.
Okay, guys. See you next week. I'm gonna schedule some additional talks. The calendar currently is empty, but that's gonna change in a day or two. Bye, guys.
All right, GG, well played. That is extremely interesting to me. Yeah, I might go ahead and take him up on that offer to talk to the CFG authors. Just because that's a good opportunity to have, but yeah, I guess I thought I had a reasonable understanding of how grammar constraints worked like that. But apparently, because that behavior is occurring, it can't work the way that I understood it to work. So now I have to figure out the way that it actually works. So yeah, interesting. I might see if I can do a stream on that myself. But I do have to shut stream off. I'm going to go to Swix's Paper Club. If there is anybody watching, I don't know if there is. I'm not going to bother to check. Come to the Latent Space Discord to see the Paper Club. If you don't know where to find it, I'm sure you can find a link on latent.space. They prefer that it is not recorded, such that we can speak freely and not have to worry about being on the internet forever. So I do have to shut the stream down in order to go attend that, but I hope to see you there if there is a you that I'm talking to. All right, later everybody.